Is there any Webex? Can anyone hear me? Hello.
Also, yes. Good evening.
All right. Hi. Is Professor Yusoff here? No. Sorry. Good evening. Prof. Yusoff, are you there?
Yes, good evening. I'm here.
All right. Yeah.
Okay.
You are here, right? You professor. So
Yes, yes.
actually, I can set you to be the.
I'm having problem with my camera. Hold on. Just now my camera was okay, but now it's not. I will log out for a while and then I'll come back in.
Okay. All right.
Assalamualaikum and good afternoon, everyone. Can you hear me? Can you see me?
Yeah. Prof. Yusoff. Yeah, I can hear you. Hi, I'm Garen. I think we.
Hi there.
Hi. Prof. Yusoff, give me I think 2 minutes. Let me settle everyone. We will have hybrid sessions. There are
Okay.
online people, or maybe you can share your screen first.
All right, sure.
I set you a presenter, right? Presenter. Prof. Yusoff, can you share now?
Yeah. Hold on.
Uh,
Okay. Somehow I'm not able to see the screen that I want to share. Let me try. Can you see my screen?
Yeah, but I think Prof, you should set your presentation mode over your side.
Okay.
Yeah, see OBS.
You can see my face, right?
Yeah, but we see the OBS background, not the presentation slide.
Can you see my slide now?
Your slide is not in the full screen. Your slide is something wrong here. Yeah, Prof. Yusoff, I think you need to share. Choose sharing and then choose the PowerPoint instead of your screen.
Okay, okay. No, actually, I'm sharing the OBS window.
Yeah, you are sharing the OBS window, correct? So what we see now is OBS instead of your presentation.
Oh, okay, then it's not working. Sorry for the delay.
Okay.
Then in that case, I just share my slide. Can you actually see my slide now?
Yes. Now we can see your slide. Prof. Yusoff.
Okay.
I think we are ready to start now. Prof. Yusoff, are you ready? If
Yeah,
yes,
I'm ready. Okay, sure, no problem.
yeah, just make some introduction first. Okay. Hey guys, just thanks a lot for coming. We are proud to have Professor Yusoff from MMU, Multimedia University in Selangor, to share the future of mobile communication towards beyond 5G and 6G. So before further, I think I pass the session to Andrea, to make some introduction to everyone about the seminar today.
I think I approached Professor Yusoff through MIM from IEEE MMU. So thank you again for becoming our main speaker for today, Professor Yusoff. So today we'll move on to future of communication towards beyond 5G and 6G. So thank you once again for becoming our main speaker. So I hope this will be a sharing session for both Curtin students and MMU students. Okay, you may proceed with your presentation. Thank you, Professor Yusoff.
Okay, thank you, Andrea. First of all, I would like to thank the IEEE Curtin student branch for having me in this session today. I can't see the audience. I did see just now, but then I'm not sure if I can see the audience. So I'm not so sure how many people are there. Yeah, I can see a few people there. Right. So thank you very much for having me this afternoon, this great Thursday afternoon. Actually, I prepared my slide for an OBS. That means I should overlay myself onto the slides, but somehow since we're normally using Google Meet and not Webex, so Webex is not really something that I'm familiar with. So I guess it's not really suitable for OBS. So you will see a little bit of in the presentation slide, it may not be something that is fit with what we have. Okay, and on another note, I would also like to thank the other organizers, the IEEE MMU student branch, the IET MMU, IEEE MMU student branch, right, for becoming the co-organizer. And since I'm also the chair for IEEE Malaysia ComSoc VTS joint chapter, then I'm also part of the co-organizer as well, right? So it's great to be here this afternoon, although we are doing it virtually. I'm not there in Curtin myself, which I wish that I'm there, yeah, but it is great to actually share something with all of you, right? Which I hope that whatever that I'm sharing with you will be very useful for your future, for your extra knowledge, etc. Right. Before we start, just to ask the organizer, are you going to do the recording for the session or no?
Yeah, Prof. Yusoff is already started recorded.
Okay, all right. Thank you. Okay, so let me begin. Before I start with the whole talk itself, right? Let me just introduce myself. Although maybe some of you already know me, I think Gary we've met before, and then a few people that I've met over at Curtin. So this picture is something that I've taken when I was there in Curtin. I don't actually remember when. I think it was 2019 or 2018. I don't really remember. It was a few years ago, before the pandemic, of course. Right. And it is a very nice place. So I really love this picture, and I think everybody that saw this picture really likes it. It's a clean beach over in Miri. Right. Back to myself. My name is Mohamad Yusoff Alias. I've been attached to MMU since 1998. That means since some of you may not have been born yet during that time. So I graduated in 1998 from the University of Michigan, Ann Arbor, US, with the degree of Bachelor of Science in Engineering, Electrical Engineering. And then I obtained my PhD from University of Southampton, UK in the year 2004. So up till today, I'm still with MMU from the tutor position up till now. I'm currently a professor at the Faculty of Engineering, Multimedia University. So my area of research is basically wireless communication, and more specifically in terms of the orthogonal frequency division multiplexing, multiple antenna system, multi-user detection, genetic algorithms in communication, multimedia applications, as well as visible light communication. So this is a little bit about me and the picture of me when I was in Miri. So I really like Miri because it's really nice. I even got to go to Guinea and explore the Guinea over there. So it's hopefully I will be able to go to Curtin Miri one more day, another time, yeah, in the future. Okay, so before we start, let's do a little bit of an exercise. So you can join in at slido.com with the hashtag, the number 3398756, just as an ice-breaking session, right? So let me share. Actually, I wanted to share something different. So join in. You can scan the QR code if you are able to do so. I believe there are also some people who are online on Webex. I think according to Min, there are about more than 100 people registered for this event, which is really a surprise since we only announced it the last 2 days. So we are receiving quite a number of people to come in. So join in to slido.com hashtag 33987756. So I'm going to stop this sharing first. I can see quite a number of people who already joined in. Okay. So you just need to answer the question there. Describe what you know about 5G in one word. So this one word cannot be 5G, of course, right? So describe it with another word that is other than 5G. Try to Okay, can you see my browser?
It's loading now. Yes, we can see it now.
Okay, you can see the result there. Describe what comes to your mind on 5G in one word other than 5G. But some of you actually type in the numbers itself. Okay, so let's see what you think about 5G. Okay, so you can see there, some people say cellular network, lightning, GGGG. That's a good one. There are 5Gs there. So someone actually put a GGGG. So that's a 5Gs. Massive data exchange, wireless. Wow, someone says sexy. Wi-Fi, flex, light, testing in Cyberjaya. There are 3 words there. Network, need new phone to sustain, correct? Right? Testing in Cyberjaya, cloud, Huawei, switching, wireless, etc. But I think one of the most important or most frequent word that you can see there is fast. Yeah? So it's right in the middle there. Someone says fast. Fast, faster, fastest. Anyone says fastest? No fastest there. Oh, I got fast. So it's a double fast or fast squared, right? So very fast, right? So basically people will think about, when people talk about 5G, people will talk about fast, yeah, fast download speed, fast smooth, right? Fast and smooth, yeah. And people talk about increased internet speed, yeah, very fast switching, flex, fastest, yeah. So basically the keyword there is fast. So everybody talks about speed, or the speed about fast, yeah. So thank you for those that have actually put in. Let me share my slides once again.
Okay, Prof. Yusoff, we can see your screen.
You can see my screen, yeah? Somehow it's a bit slow today. All right. So basically, when we're talking about communication, communication has become an important part of our daily life. Is becoming a significant part, especially mobile communications, of course, right? So without communication, if you look at it 10 years ago or even 20 years ago, communication is not as significant as it is today. Nowadays, everybody holding their phones, everybody is looking at their phones, whether they are actually chatting with their friends, whether they are looking at apps, everything is in terms of in the phone. So phone has become a significant part of our life. And during the pandemic, phone is not just, or communication is not just being used to communicate with each other, exchanging information, but they are also being used for learning. For example, for online learning, people are using it for having their online classes, because we are not able to go, the kids are not able to go to school, the students are not able to go to their universities or colleges, so they have to study from home. So communication has become an even more important part of our daily life during the pandemic. Moreover, we are using our phones for driving. No one is using a GPS. Everybody is using a GPS in their phone nowadays, no longer having a separate GPS device like the last 5 years or 10 years, right? People are also using their phones to communicate with each other, like what we are doing today. So I don't have to be there in Curtin personally, and you don't have to come to KL to meet me. So we can have our sessions online. And during the pandemic, this has become a norm where we have online meetings. Other than the online classes, we also have online meetings, we have online seminars, even the conferences have been online. So everything has moved or shifted towards online and make communication even more and more important. And with the advancement of, for example, e-wallet, right? So the handphones or the device that we are using are no longer just a handphone, but it also carries our money with us, right? So when we go around to shops, we can just use our phone to buy things. We can order everything online with Grab Food, with Food Panda, with all this online shopping, for example, Lazada or Shopee, etc. So, excuse me, sorry. Is there a question? Okay. So if you are using your phone, you can actually use your phone for a lot of purposes, right? So your phone has become, or your device or communication has become an essential part of our daily life. It's no longer just a simple device. It's not just a device to communicate or to call each other, but it has become the device is like a multi-purpose device. Even it is used for alarm clock, it is being used for example, as a camera, as a video cam, right? Everything is compressed into just a single device, right? Before we go into more details, right, just a little bit of communication, because I know some of you may not be from a telecommunication background. Some of you probably are from electrical or electronics background. I know a few people, like Min, for example, is from electrical background and not telecommunication. Telecommunication is a very wide area. It's huge. There's a lot of things in telecommunication. One of the ways to divide telecommunication is to look into the technologies that are related into two parts. One is called wired, and the other one is called wireless. Of course, when we talk about wired, we are talking about something that is connected using cables, right? So when we have anything that is connected with cables, then we call them as wired communication, right? Such as the RJ45, USB cable, you have copper cable, fibers, and so on. Those are wired communication. On the other hand, when instead of using wire, that you don't have wire at all, you remove the wire, it becomes wireless, right? There is no wire, less wire or no wire, so it becomes wireless. So there are two main types of telecommunication in general. One is a wired, then the other one is wireless. So the one that we are going to be focusing on today will be on the wireless, right? Actually, wireless, even wireless, is huge. there are so many types of wireless communication. So you can categorize wireless communication into different types of wireless communication. So based on the range or the distance that the signal can travel, so if you look at wireless communication, the signal actually travels using radio wave. So radio wave is something that we cannot see that is coming out from the device. So the information is actually being transferred or being carried over using radio signals. So it's coming out as radio signals, and at the receiver there will be an antenna that will be picking up the radio signals and convert that back to electrical signals. So the transmission is using radio. So the wireless technologies themselves, there are so many wireless technologies, right? So you can divide the wireless technologies into different types based on the range that it can go. For example, there is what we call the wireless personal area network, or wireless PAN, which is covering a small area. So you can imagine, for example, it can cover about 10 meters square, or 10 meters, 10 meter radius, right? 10 meter radius. So this is a short distance type of communication. For example, Bluetooth is something that you are normally using for your headphone, your headsets. Even myself, I'm using a Bluetooth, Bluetooth mouse. And then I have a remote control that is also using like a short distance infrared or Bluetooth, right? So these are only for a short distance. The reason why it's called personal, because it's only being used in a personal domain. It's not being used in a wide domain. It's only a personal area. So even this type of wireless personal area network, there are different types of standards or technologies in there. The one that is very popular to us is, of course, Bluetooth. We are using Bluetooth for our headsets, for cameras, etc. So we use Bluetooth a lot. But other than Bluetooth, there are also other types of technology that are not that common, like Zigbees, ultra widebands, even infrared can be considered as wireless personal area network. So when we go slightly bigger into a slightly bigger area, we call this as a wireless local area network, or wireless LAN, right? So of course, the word wireless LAN or IEEE 802.11 may not be something that is very common to you, but you definitely are using Wi-Fi. So Wi-Fi is the commercial name, or it's actually a trademark name under another group, but using the IEEE 802.11 standard, and this is one of the technologies under the wireless local area network. And normally wireless local area network, if there is no blocks, or there is nothing that is nothing that is blocking the signals, it can go up to even about 100 meter radius, right? So this is your Wi-Fi that you are using. Then if we go even bigger, then we have what is called the wireless metropolitan area network. And one of the examples for wireless metropolitan area network is WiMAX. Although WiMAX is already obsolete, probably you never heard of that. Some of you may not have heard of it or may not have seen it. We used to have it around 2008, 2012, last time in Malaysia under YTL and also under P1. But nowadays, WiMAX is already obsolete. You can only find it in the Telecom Museum. You can't find it anywhere else. Then we go even a much bigger area. This is called a wide area network, wireless wide area network. And the best example that fit this wireless wide area network is, of course, our mobile technology or our mobile communication, right? Other than that, for example, satellite communication can also be considered as sorry, any question, Aidarus? Any questions? So if you do have any questions, then you can actually ask questions. And the much bigger area will be the wide area network. So this wide area network covers, like, for example, the whole country, or even a much bigger region. So a very good example of this will be the mobile communication. So as you can see, mobile communication is actually just a small portion. It's only one type of a wireless communication, which is also a one type of the whole telecommunication. So if you look at it, it's just like a small grain in a pot, or a small grain of salt, yeah, or a small grain of sand on the beach. So it's only a small part of the whole telecommunication system. So the whole telecommunication is huge, right? So when we go and dive down into mobile, it's even bigger, right? There are so many things involved in mobile. So mobile communication, why do we want to dive into mobile? Why is the topic today is related to mobile communication when we have so many other types of communications around, but we want to focus on mobile, right? So if you look at the statistics given by the International Telecommunication Union, or ITU, this is statistics based on at the end of 2021, you can see that the number of mobile subscribers compared to the number of fixed telephone subscribers. How many of you still have fixed telephone line at home or fixed telephone line in the office? Almost everyone is using mobile phones now. So you can see that the number of mobile cellular telephone subscription, which is the gray color, is far exceeding of the fixed telephone line, of the fixed telephone subscriber, right? This is the fixed telephone subscriber. And you can see that the fixed telephone subscriber is declining over the years because less and less people are actually using fixed telephone lines nowadays. So the number of mobile subscribers is actually increasing over the years. So there are more and more people switching towards mobile phones, right? Even the number of mobile broadband, because some of these mobile phone users may not be using mobile broadband. They may be using just the 2G cellular system, which doesn't have broadbands and so on. But you can see that, for example, the number of mobile band subscribers, the yellow color or orange, whichever that you see it, is also increasing, and it seems that it's going to converge with the number of mobile subscribers around the world. So that means almost everyone that has a phone in the world later on will switch towards mobile subscription or mobile broadband instead of the fixed broadband. And you look at the number of fixed broadband, there are not that many people are subscribing to fixed broadband because, like for example, if you have one subscription at home, there are 5 people or 6 people using that only one subscription. Whereas for a mobile phone, I may have one phone, right? I tell you a secret, I may have one phone, but I have 2 SIM cards in that. So I'm one of those that guilty of having more than one subscription for one individual. So that's why the number of mobile subscribers, if you look at this is per 100, maybe yellow is not that clear. If you look at per 100 subscribers or per 100 inhabitants, there are more and more number of phones or more number of subscriptions compared to the number of inhabitants. That means for 100 people in the world, there are more than 100 subscriptions or more than 100 SIM cards or more than 100 numbers for these 100 people. That means the demand for mobile is actually increasing. So over the years, we expect that it will keep on increasing, and for the next few years, definitely there will be more and more people using mobile phone. But the problem around the world, this is something that we're going to discuss later on as well when we talk about 6G. There is a what we call a digital divide. You can see that, for example, most of the developed countries are having a lot of subscriptions, but at the least developed countries or those that are developing, you will see that there are still lack of mobile subscription. So there is a huge digital divide between the least developed as well compared to the developed countries. And if you look at the average for the world, the number of subscriptions on average throughout the world, the least developed and developing countries are actually below the average number. So we are still lag behind. And later on, you will see that this is also one of the motivations towards 6G, right? Why we are going towards 6G. Yeah. And back here in Malaysia, we can see that if just now I was showing you the details of around the world. So this is the data that is taken from MCMC. They always come up with the facts and figures every quarter. So this facts and figure is at the end of quarter 4 2021. That means by the end of December 2021. So you can see that the number of mobile broadband subscription in Malaysia is 42 million, and 41 million of it, right, is so you can see that there is an increment from third quarter of 2021, which is only 41 million to 42 million. There is an increase of about 400,000. Yeah. So there is more number of mobile subscription. How many, what do you think is the population of Malaysia? And anyone has a guess? It's about 32 million, including kids, babies, old people, and so on. So can you imagine there are 32 million people, about 32 million, not exactly, I don't remember exact number. There are 32 million people in Malaysia, but there are 42 million subscriptions in Malaysia. So on average, one person at least have about 1.5 number of subscriptions. Of course, again, I said I'm also guilty of that because I actually have more than one subscription. I'm one of those who actually have more than one numbers. Yeah. So that means the number of mobile subscriptions is increasing every year. So you can see, for example, the penetration rate is 144%. That means for 100 people, there are 144 mobile cellulars. Yeah, so that is 1.4 for each person, including babies, including small kids, and including the old person. Right. So that is how mobile broadband is increasing every year. So you can see the demand for mobile is going to increase. Yeah, is also very high. Right. So now, before we go into 6G, let's go back to what is the hot topic today, which is on 5G. Right? I get a lot of questions when the announcement came out. I think also Min also put it down in the Facebook page. 5G is not here yet. Why are you discussing about 6G? Right? So people have not even got 5G. I have not subscribed to 5G yet. So, but we already have we are already talking about 6G, right? So before we go into 6G, before we jump into the 6G ship, let's start talking about 5G first. What is the G in the 5G? Just now someone was writing, what is 5G? So his or her definition of 5G is when you have G, 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 G. So there are 5Gs, which is true, correct? It cannot be false, right? Which is true. You have 5 letter G's, right? But what is this G stands for, right? I'm sure everybody knows. Yeah. So that question. So G stands for generation. So when we're talking about mobile communication, we talk about 5G. That G is talking about generations. And why is it generations, right? So there is a reason why they call it generations. Generation is when you change from or you have a total revamp or a total change from something and you move to something else. Just look at us human beings, right? For example, those that were born in the 1960s or 1970s, they are called baby boomers generation. Then those in the 70s is Generation X. Then those are born in the 1980s, we call them Generation Y. And then those that were born in the 1990s are Generation Z or Generation Z. And then those that were born around from 2000 to 2010, they are called millennia. I'm not sure what they call them now, right? But I think most of you are either the Generation Y or Generation Z or Generation Millennia, right? So that is in terms of human being. So why are we calling this generation, the different in terms of generation? The reason is because there is a total revamp, a total change of everything. That's why it is called generations. If you only change a little bit here and there, we don't call it generations. So mobile communications also start from the first generation. So the first generation is started around 1980s. Actually, even before 1980, there was already mobile communication, but it's not widely used. If you go back into history, if I want to go into history lesson, sorry if I go into history lesson again today. So if you go back into history, radio communication actually started when Marconi, during the time when we have Tesla, Hertz, etc. back in the late 1800s. They were the one who started with the radio transmission. And then when there was World War I and there was World War II, that's where radio becomes very common among the military services. They use the Morse code, for example, to transmit data or transmit information between their teams and so on, right? And then after World War II, then only the radio becomes into the public domain. And then you have like walkie-talkie, for example. And then in the 1960s, 1970s, a few companies actually came up with cellular communication, but at that time, most of these communications are considered as proprietary. When we say proprietary, it means that they are basically owned by certain companies. And so these companies, they have their copyrights, they have their patents. So if anyone else wants to use it, they have to pay the company in order to use that particular system. So when you have this the what you call proprietary types of systems, is not a standard. It's not something that is open to everyone to use. So it become quite expensive. Not that many people will be able to use it. Not and many people can afford to actually use it. So the actual first generation, or what we call the first generation, is launched around 1980, when in the US they have what is called the M systems. And then in the Europe, different countries in the Europe, they have their own system. They have like the tax system. They have in Scandinavia, they have the 450 Nordic, I think is what it's called. In German, they have their own system. In France, they have their own system, and so on. So different countries have their own system. But the main feature of this first generation was that it was using analog. So it was using analog circuits, analog communication, and it was mainly for voice. Because at that time there was no such thing as internet. So the phone itself is to replace the fixed line phone, or something that you can move around, so you can take that phone with you. But you can see, if you happen to be in KL, there is a museum called Museum Telecom over at Jalan Raja Chulan in KL. You can visit Museum Telecom and you can see this first generation phone. So the size of the phone itself is not something that you can put in your pocket. It's something that you have to carry with you. The reason why they call mobile is actually most of the time is fixed in the car or inside the automobile. So that's why they call it mobile, right? So it's quite big and bulky. So it's not really something that is convenient. It's expensive, and it's using analog. So analog, the problem with analog is that it's noisy. I still remember doing my practical when there is no security in this analog communication, where you can take a handle and tap into the signals and you can listen to other people's conversation. So that's how insecure this first generation was, right? But this is a starting point. So you have to start somewhere. So the mobile communication starts from there. So this is around 1980. So about 10 years after that, this is when the second generation comes in, right? And the second generation has moved from analog, instead of using analog, now instead is using digital, right? So at that time, the digital circuits has become cheaper, and it becomes like, for example, microchips. The electronic circuits have become cheaper and smaller, so they were able to come with a much secure system. When it is digital, you can encrypt the signals, you can put extra security. And then when it is digital, you can merge a few sources together. So it actually saves a lot of the spectrum. We'll talk about spectrum later on. So that means there are more users that can be supported in the second generation. So remember earlier on, I said, why is it called generation? Because when you overhaul everything, so that means everything needs to change. The whole system from the user end, from the handphone up to the base stations, up to the network, everything has to change. That's why it is called a new generation, right? So the second generation is also an evolution because this is a starting point for digital communication. So everything starts to move toward digital and never go back to analog, right? The digital system also introduced extra services other than just voice. It improved the voice. There's no more noise. In the first generation, if you actually happen to use the first generation, there was like screechy sound, that's noisy sound. But when you use digital, it's very smooth. They can remove the noise out of the signals coming in. So it's improved in terms of voice communication. There was an added security because you can encrypt. So anyone who taps in, they won't be able to listen anything because it's secure. The signals that is transmitted, so you don't need to worry about your conversation because no one else can actually tap into your conversation. It's all secure. It's encrypted, right? And the coverage also is bigger because now you can actually support more number of users, and there are extra services that is provided together, right? During the second generation, this is when the short messages system was introduced. It's something that you use up till today. You still use SMS, although mainly for like tag or tag numbers or something that you want to get informations from the agencies, etc. You use SMS. But it was introduced back in the 1990s. It was introduced during the second generation. Other than that, it can also carry a small amount of data, like for example, for facsimile, although no one is using fax anymore today. And it has services like caller ID, voicemail, there was a teleconferencing, etc. That was introduced in the second generation. So the second generation was a revolution. It's considered as a revolution because it changed the way that we actually use our handphone. It becomes cheaper, it becomes more fancy, there are more colors, etc. because there is a SIM card introduced, then people can change from one phone to another. Then there was I think it should be inside here, 1G, 2G. Then this is the third generation, right? So the third generation, moving from the second generation to the third generation, it takes about another 10 years, right? So at that time, there was internet started to become something that is very common to the public. A lot of people are using the internet. So the demand for internet in a mobile phone become bigger. So they want a higher data rate. For the second generation, it can only carry about 9.6 kilobit per second. And I'm sure you look at it, what can you do with 9.6 kilobit per second? You can't even send a photo, moreover the video, right? So you need a much higher data. So that's why the third generation comes in, right? So third generation incorporate both voice, should improve my handwriting. So you have both voice as well as data, right? So if the second generation, the first generation is mostly for voice, the third generation is when the voice plus data comes in, right? So during the transition from each generation to one generation, actually there is a catalyst. There is something that push the generation to comes in, right? So the catalyst from the first generation to the second generation, you can call it digital, because everything become digital. It's a digitalization that actually push from the first generation to the second generation. The push from the second generation to the third generation is the internet. So internet becomes more public in the public domain around 1994. Again, I think most of you were not born yet during that time. So it became more public. Then people were thinking about how am I going to use the internet on my mobile phone? So we need a higher data. So in between, as I said, to move from one generation to another generation, you need a total makeover. That means from one end to the other end, the whole thing has to change, right? And it is very costly. It's not that cheap to, go from one generation to another generation. It's very expensive, right? So that's why in the middle, there was also what is called the 2.5 generation. So the 2.5 generation is not really a new generation. It's actually an add-on. So there was an add-on called Edge, GPRS, and combination of both with EGPRS, right? Mainly to support the data, right? But the type of network is the same. So this is using switching network because it's suitable for voice. So using switching. Circuit switching. This is also using circuit switching. But here, in order to support a higher data, there are two types of switching that were used in the third generation. For voice is using circuit, and for data is actually using the packet switching, right? So packet switching is more suitable for data, and circuit switching is more suitable for voice. So in the third generation, actually they have both. They have voice and also packet. So this was around the year 2000 where internet started to catch up and a lot more people are started to using internet. Then we move to the fourth generation. So this is when data takes over the voice. There is no longer people using voice calls. People are mostly using data. Nowadays, you look at people who are using apps. Even we are using what is called the voice over IP, right? And in 4G, there is a specific type of voice over IP, which is called voice over LTE, right? So the fourth generation is basically instead of having both circuit and packet, it is optimized by having only packet-based packet switching, right? So we are basically introducing only packet switching. We're not using voice circuit switching anymore. So what happened to voice? So voice also have to move towards packet. So that's why they have what is called the voice over LTE, right? And this happened around 2010. So you can see that the jump, okay, I already talked about the catalyst just now. What is the catalyst or the push, the push factor that actually creates this generation? So what do you think would be the push factor from 3G to 4G? Anyone? What do you think? Any guess? So data rates,
Channel capacity.
channel capacity, okay.
Applications,
Applications, what kind of applications?
real time,
Speed, sir.
real
Oh,
time.
Prof. Noor is answering it.
Well,
Not fair, yeah?
video.
Not fair, it's a
Yeah,
prof.
just playing. Thank
Now,
you, Prof.
actually, the answer, thank you for joining, Prof. Noor. Prof. Noor is from UPM. She's an expert, so I'm scared that I will talk something wrong here. The catalyst for the fourth generation is actually smartphone. So if you look at smartphone is actually nothing new also. If you remember back at the end of 1990s, in the 1998, when I was graduating, there was the Palm Pilot, there was BlackBerry. That was considered as a smartphone, but it's not really smart enough because those smartphones are using specific operating systems like Symbians and so on. They are not using an open source type of operating system. So the one that really pushed, the push factor, the catalyst for this fourth generation was actually the introduction of iPhone or even iPad back around 2007 or 2006, right? That was actually the catalyst that push the mobile communication or mobile technology towards having a much higher data rate or into the 4th generation. So when Apple introduced iPhone, it became a popular device, right? If you remember last time, Nokia used to dominate the second generation and the third generation. There was about 90%, more than 90% of the mobile market at that time was conquered by Nokia. But when Apple introduced iPhone and then later on Google follow up with an Android phone, so you have two types of smartphones that actually started to conquer the market. And around a few years back, Samsung become like almost conquering almost not really the whole market, but it's one of the major player in the smartphone markets. The introduction of this smartphone changed a lot of things. Someone answered just now about applications, right? That's why application is the one that is used in the smartphones, right? When the smartphone was introduced, iPhone was clever because they introduced a way that users can actually create their own applications. Before that, it was very difficult for those who used to use programming Java into the third generation phone. You know how difficult it is to actually program Java into the Java mobile. Then when they introduced iPhone and also Android phone, users can actually create apps. So that's why people start to come up with all sorts of apps. And with the apps, there was a demand for higher data rate, right? You can't even support the data rate that was supported by 3G earlier. So when we talk about 2G, it was about 9.6. In GPRS, we can support up to 384 kilobits per second. And then in 3G, at the beginning, it was about 2 meg, right? So in the year 2000, 2 megabits per second was, wow, it's already fast enough. But by the time iPhone came out, 2 megabits per second is not enough at all. So that's why, and again, in order to go from one generation to another generation, it's very costly. It costs a lot because you need to change everything. So there was also in the middle the 3.5G. This is the HSDPA, HSPA plus. Sorry, I don't have enough space here. HSPA plus, which can go up to 8 megabits per second and even higher than that, right? When 4G came out, it actually can go up, it promised to go up to about 1 gigabits per second, although most of the time you don't really get it because that's the best case scenario. If you're the only person that is actually using it, perhaps you can go to up 1 gigabit per second. But since we are sharing with everyone else, you don't really get that 1 gigabits per second. So now we are talking about 5G. It's an even higher data rate. So what is difference between 4G? What is the difference between 4G and 5G? Why now we are going towards 5G? So there is something special about 5G that is slightly different than 4G. So 5G is still following 4G, which is everything will be based on packet. We're not going back to the circuit switching anymore. So voice will also be carried over on packets, right? But the one thing in 5G that is different compared to 4G, other than carrying a much higher data rate, if 4G can go up to 1 gigabits per second, this one can go, the 5G can go up to even 10 gigabits per second or even higher, right? Greater than 10 gigabits per second. But the difference now is that in 5G is not only talking about the data rate, so we're going to look at that later on, but there are also two other features that is incorporated, which is looking at a massive machine type communication and ultra reliable low latency type of communication. So you can see that the difference between one generation to another is roughly about 10 years. So it takes about 10 years to go one generation to another generation. So 5G, as I said, there are three promises given by 5G. So there are three key features. So even if you don't get anything else from today, at least you remember these three key features. It's like a triangle here. This is not Illuminati, so this is a triangle for the promise of 5G. So you can see from here, there's the enhanced mobile broadband. So this is the one that we're talking about, going up to 10 gigabits per second. It's talking about a high data rate. It's already written there. And then there are two more key features that was not actually there or not really focused in the fourth generation. The first one is called massive machine type communication, where we are talking about 1 million devices being connected in 1 kilometer square. Yeah, so you just imagine that there are so many devices connected together. If earlier on we talked about devices being just phones, but now devices can be anything. It can be your microwave, it can be your TV, it can be your fridge, it can be your washing machine, it can be your alarm, security alarm. People were even talking about smart diapers, where they can have chips inside the diaper, so you can tell whether the diapers need to be changed or not. So this is more commonly known as the Internet of Things, to support Internet of Things. And the other part is what is called the ultra reliable low latency communication, or URLLC, right? Previously, in previous generations, they don't really care much, or they do care, but they don't really reach up to about 1 milliseconds of delay or latency. Latency is when you need the response back. So when you type something, it goes to the server and comes back to you. So that's the delay. That's a long trip or a round trip delay, going from your phone to the server, coming back to you is a round trip delay. So based on the transmission, which is running in the speed of light, so there must be a certain delay, right? Although it's 3 times 10 to the power 8 meter per second, but still the distance that it needs to travel is thousands or even hundred thousands of kilometers away. So definitely there will be a delay to come back and forth, right? So in 5G is a promise to come, the latency or the response should be lower. So it should go below 1 meter per second. Why is it 1 meter per second? There must be a quick response, especially for things that are crucial in terms of having an instant action. For example, autonomous cars. Yeah. So autonomous car needs a fast response, or else you start hitting all the other cars. Yeah. So if you watch, there was one video of people driving in Malaysia using Tesla cars, right? So although that's not using 5G, that's using just the normal, maybe just 4G, but it's still able to use it. But with the if let's say most of the cars become autonomous, then you need a much bigger network. So that's where 5G comes in. Another example for the URLLC is, for example, in manufacturing. So if you go into manufacturing where they have smart manufacturing, they start to use, for example, machines that need to do a fast response. So they need something that is low latency. And at the same time, when you talk about ultra reliable, we're talking about 99.99% reliability. That means there is a very small room for error, right? Very, very small room for error. So these are the 3 aspects or the 3 key features of 5G, right? So 5G is also being related to the 4th industrial revolution, right? I'm talking about 5G first because later on we will move into beyond 5G and 6G. It's already 6 o'clock. Hopefully I'm halfway through. I'll try to go slightly faster. Yeah? So the 4th industrial revolution is where the industries are moving from before the 1st industrial revolution, which was around 1700s. I think it was 1760s. There was a first industrial revolution where people start to manufacture in a factory, but at that time it was using machines with steam-based machines, right? There is still no electrical power and so on. But when we talk about revolution, it changed. Yeah, revolution is change. It's a drastic change. So it moved from steam-based machine to the 2nd industrial revolution, where it moved into energy-based, where there is electric, where there is coal, and so on, or oil and other sorts of sources for the energy-based mass production. So this is around 1800s. And then there was the third industrial revolution around 1960s, where people are talking about computer-based machines, right? There was the third industrial revolution, and now people are talking about the fourth industrial revolution, where it's an intelligent-based business model. So how does this relate to 5G? So the fourth industrial revolution is also part of a digitalization, right? There are many types of technologies or types of, if you look around today, right? People are hyping about a few types of things or technologies or what do you call it? Create a new scheme or something new that is come up with in the industries. People are talking about big data, right? Where data becomes even more expensive than gold now, right? So data has become something that is very precious. Yeah. So big data is something big, is a huge topic right now. The industries, all industries are talking about big data, how you're going to process the data, and so on. So big data is one of the aspects of digitalization that we see today. AI is another one, artificial intelligence, right? So everything wants to incorporate into artificial intelligence where machine can think on its own without having to have humans to interfere with it, right? So this is where artificial intelligence come in. Another technology that has become very popular today is cloud. Yeah, I'm sure all of us are using, for example, cloud storage. We have Google Drive, we have the OneDrive under Microsoft, we have Dropbox, etc. Those are under the cloud storage. But cloud is not necessarily just storage alone. Nowadays, we also have cloud processing and so on. And even in telecommunication, we have a cloud radio access network. So even in mobile technology, we are moving towards cloud, right? So what does all this have in common? In order to communicate between the different technologies together, you need a very good connectivity, right? Connectivity is significant now. Take, for example, cloud. Yeah. So nowadays, if you buy phone, you no longer need to worry about having an SD card, an extra SD card to store your pictures and so on. Because once you take the picture, you can always upload it into your drive. You don't need to store it inside your phone anymore. But in order for you to store in the drive, what do you need? You need connectivity, right? So this is where 5G comes in. So 5G is the one that is going to link all these technologies together, right? The one that is going to incorporate the technologies together. They are symbiotic, where they work with each other, they help each other, they actually work better together, right? Rather than stand alone, right? So in summary of the 5G use cases, it's not the end yet. So I'm only looking at the summary for 5G first. So 5G is looking at not only human to human, this is what we are doing now, human to human communication, but it's also looking at human to machine. We already started with human to machine. For example, you communicate with machine, with vehicles and so on. But in the future, we are also talking about machine to machine. That means you don't need to have human interfering or human in between the technologies. Yeah, so it can be done by the machine themselves, right? So this is the way forward, the way that we are going to look into the future. So you can see for human, you have the social networking, wearables, video calls, that's what we are doing now, public safety, etc. But human to machine, example like smart homes, smart cities, remote surgery, vehicle to pedestrian. And then when we go to machine, we're going to talk about the vehicle to infrastructure, like imagine your car can communicate, or the traffic light communicate with your car, right? Or your car communicate with the traffic light, or your car communicate with another car, right? Or another vehicle. So that is where machine can communicate with another machine. Similarly, in the industries, people are talking about automation, where machine can talk to another machine when they are doing their production, right? I'm going to show you actually this one, the current stage of 5G throughout the whole world, but I think we may not have time to do it, and it's not really easy to switch from the slide to the browser. So if you want to look at the coverage, you can go to Ookla. Ookla has a 5G map. This is an interactive Ookla 5G map. If you look at it, there is some parts in Malaysia that is already having 5G in Cyberjaya, Putrajaya, and also in KL. We already have 5G, but the rest of the world also there are a lot of 5Gs going around. Yeah. Okay. So now, right, the topic that we're going to focus on today is what is beyond, right? So some of you may be asking, hey, I haven't even got 5G. There is not even 5G in Malaysia. Now it's 2022. Why do you want to talk about 6G when 5G is not yet there, right? So we have to look at the history, yeah? The one that I already presented earlier, the history. So it takes about 10 years to go from one technology or one generation to another generation, right? So 2020 was commercialized, I think around 2020, 5G was commercialized around 2020, although up till now, in Malaysia is still a bit slow. So you don't need to worry about that because the adoption of technologies usually also take time. If you remember back for 3G, yeah, I remember back in for 3G, it was launched in the UK in around 2000. Malaysia only adopted or even launched it in Malaysia in around 2005 when Maxis and Celcom actually introduced 3G in Malaysia. So how many of you actually started to use 3G? Not in 2005, yeah, right? So you probably use only 3G like after 5 years or after 6 years. What about 4G? 4G actually came out around 2010. In Malaysia, we started around 2012 by Maxis, right? How many of you, even myself, I'm guilty for that. I only use 4G only in the past few years, only maybe around 2017 or 2018. And only recently 4G becomes popular with 4G LTE-A, etc. So the number of years that it takes from the day that or the time that that technology is launched towards the adoption, it may take some time, right? So we human beings always have this kind of wait and see rather than straight away jump on the wagon and start to use that technology. So most probably, even though 5G is not here yet, you should expect the rollout throughout the whole country by the year maybe 2025, and maybe 5G will be only started to become popular by end of 2030 or 2028, 2029, right? So why do we want to start talking about 6G? Because the time that it takes for research, the time that it takes for standardization is a bit longer than it is. Something that we are doing today, right? For example, when we do a research on 6G now, and today you see a lot of research going on in 6G. I will introduce some if we have time later on. So the research is already ongoing. The initial stage or the starting point already started even before 5G was rolled out, was started in around 2018, 2019. So people already talk about what is going to happen. So the research is because when we do it, it takes time. It takes sometimes before something can even be rolled out, right? So it takes about 10 years roughly to go from one generation to a generation because of the time that it takes for standardization. So standardization is not an easy process because it needs to go through meetings, it needs to go through paperwork and so on. I think Prof. No one knows about this. When we have standardization in Malaysia, it takes more than 10 meetings to even come up with one standard. So it takes a long time to even formalize a standard. And the idea or the plan is not for something to be used tomorrow. It's not something to be used next year. It's actually when they plan for 6G, they actually plan for the technology to be deployed between 2030 and 2040. So when we design something, we design of what is probably going to be used in the future. It's not something that will be used today. It's not something that will be used tomorrow, but in about 10 years time. Yeah. So let me share you a video clip. This is from YouTube. You'll see the world in 2030. Okay, I think I will. Okay, I think I will stop here. Some of the information has already been there. And you can watch this on YouTube, The World in 2030, Top 20 Futures Technology. So why do we need to have a look at this kind of videos? Is similar to how we want to imagine what the future will be. So when we look at what the future looks like, then only we know what kind of things that we want to invent or what kind of technologies that we can fit into it, right? So this is where 6G comes in. So you look at the 2030, because as I said earlier, we are talking about 2030s. We are talking about the creation, a generation for 2030 to 2040. So we are thinking about another 10 years from now, not for something to be run today or not for something to be used tomorrow. It's something to be used another 10 years. So that's why we need to see what will be the demand, like in 10 years time, right? So before we go that, let's look a little bit in history. Actually, back in 1926, Nikola Tesla, right? This is where the name Tesla comes from, right? The visionary Tesla, Nikola Tesla, has stated that when wireless is perfectly applied, the whole Earth will be converted into a huge brain. So he said about this about 100 years ago, about 96 years ago, right? So this was 96 years ago, yeah, almost 100 years ago. So he already mentioned that when wireless is perfectly applied, the whole Earth will be converted into a huge brain. And this is what by 2030, this is what going to happen. Because if everything is connected, the connection is everywhere and everything is using wireless, this is exactly what Tesla has predicted about 96 years ago. So by 2030, responding to the fundamental human and social needs based on the expected progress in ICT, Tesla's prophecy may become a reality. So that's sometimes a dream can actually become reality if you really look at it. Yeah. So 4G, the one that we have introduced earlier, the 4th generation and the 5th generation, actually has started to address some of these challenges that we have been facing, right? But this is only a beginning because it's going to go even further and further, right? If you look at technology, it's never going backwards, yeah? From one generation to the second generation, it's going from analog to digital. It never goes back to analog, right? And then when we have the third generation to the 4th generation, we're going from circuit switch plus packet switch to totally packet switch. Everything is all IP. Then it doesn't go back, right? It won't go back to the previous one because the technology keeps on improving. That's what we are doing when we do research, for example. We try to improve things. We're not trying to go back in time, or we're not trying to go into the earlier stage, right? So 6G actually will provide the infrastructure that enable the end users to perceive themselves as if you have a huge artificial brain that is offering a zero latency services, unlimited storage, and immense augmented cognition capabilities. So basically, you're talking about everything can be taught. This is where the low latency, if you remember, that in the 6th generation, it will be talking about zero latency. So if in the 5th generation is 0.1 milliseconds, you're talking about even smaller than 0.1. You go very, very small up to virtually is zero. Yeah. So this is where 6G is going. But when they are talking about 6G, right, nowadays people are also talking about sustainability. So among the issues that is very strong or very common now or very important that people are discussing or researchers even research, when we are doing research, we always talk about what is the impact of that particular research to the environment. Yeah? So we have to take care of our environment, and we have to make sure that our environment is there for the future of our kids and our generation. Other than that, you also have to think about society, where the society is, what is the importance of the society. And of course, people are talking about economics, basically on in terms of the monetary terms. So among the total today's issues will be the social issues, right? The coverage. We talk about digital divide, where digital divide is looking at how the gap can be closer, right? But unfortunately, if you remember the ITU graph that I showed you earlier, the gap is actually become bigger and bigger. That's one of the things that they are afraid of when 6G is introduced. It may not actually close the gap, it will actually widen the gap. So that's an issue about people not having connectivity. Even now, having connectivity is considered as a luxurious item, and although is significant, although is considered as a necessity, right? But some people are still without connectivity, right? And they are lag behind even in certain areas, like when everything becomes internet based or online based. Those without connectivity will have difficulty in getting the services. Another part of sustainability would be when you talk about environment, you're talking about the energy, the amount of energy that is being used, right? And that's why in communication, we always talk about green communication. How do you actually improve the communication, but at the same time, try to make sure that the environment is being preserved. It's not going to take the toll of the environment. Another part will be, of course, on the concern of the electromagnetic wave. Although we have to, we know that the radio wave that we are using are not really harmful because it's a non-ionized radio. But people always have that they are always skeptic when there are something new. When something new is being introduced, they feel that is it safe? They will have that questions in them, right? Especially if the spectrum that you are using, for example, those with a very high spectrum, like the millimeter wave, they are not being used yet. They are not being tested yet. So people are very skeptical about that, right? And of course, security is also an issue when people are looking at the bigger the connectivity, the easier there is the scammers and the hackers and so on that will steal your information and create problems to the users, right? So when we have 5G, this is again the questions that people will probably ask. We already have 5G, so why in the world you want to think about 6G, right? But that's not how researchers look at it. That's not how people, although the end users probably say, hey, we have 4G already, 4G is good enough now, why do we need to go to 5G? Why do we need to go to 6G? But people have to look at it again, that what we are inventing, what we are looking at now is not for something to be used tomorrow, right? And definitely when you look back at the history of from the one generation, from the 1G to 2G to 3G to 4G and then to 5G, the same thing happened previously as well. When there was 3G, they already have 2 megabits per second in the year 2000. People already said, well, 2 megabits per second is more than enough, because at that time people were using dial-up, which is only about 52 kilobits per second. So 2 megabits per second at that time may be enough. But by the time 2005, that 2 megabits per second is not enough anymore. Similarly, now we are using a 4G, which is probably can, if you get a good connection, you can actually go up to 50 megabits per second. But if you want to watch a small YouTube channel, 50 megabits per second is good. But just imagine in the future, people are not talking about 4K, people are talking about 8K types of movies. People are not talking about just the normal 2D version. They are talking about augmented reality and virtual reality. So there is a need for a higher technology. Actually, technology and new services and applications are like the supply and demand. right? So they are more like supply and demand for those who are taking economics. Though I used to take economics, only a small subject of economics, but I do learn about supply and demand. When there is a demand, there is a supply. So when there's a supply, but there is no demand, there is no point. So when technology comes in, there is a reason for this technology. There must be a demand for that technology, or else that technology will not be used. Just look at some example of technology that is becoming obsolete, like WiMAX, as I mentioned earlier. WiMAX was good because it's for fixed wireless, but when it comes to mobility, WiMAX is not there. So that's why people are not really using WiMAX. People opt for LTE-A instead, right? Because LTE-A can support mobility and fixed at the same time. So they will go for LTE-A and they just dump WiMAX on the side, right? So there must be a supply and demand. So similarly, in 6G cases, there is a supply and there is a demand. So the supply that we're talking about is the research that is ongoing. I will talk about some of the research in 6G that is ongoing later on. The demand that we are looking at is the application and use cases. Although I shared with you just now some of the example of 5G use cases, but there has already been demand for a 6G level type of services like the remote surgery. We're not just talking about augmented reality, we're talking about extended reality, where we have augmented, we have virtual, and also mixed reality merged together. So it become a new applications in the future, right? So some of the examples that I'm showing here is for beyond 5G services. We're talking about social problems like remote surgeries. Nowadays, people can do, the surgeon can be somewhere in the US or in Korea, and the surgery can happen in Malaysia, for example, right? Or especially in when you're talking about remote areas where you cannot transfer the doctors to that site, you can have the machine on that site instead, and then we can have the remote surgery there, right? I have some friends in your ITM hospital where they're already doing some remote surgery with surgeons from South Korea, right? So it's already happening. Okay, there's also communication between humans and things. Of course, now people are talking about Internet of Things. You're already communicating with machines, although it looks like crazy, right? When you're talking to machines or non-human, as if you're talking to yourself, but we're already talking to yourself, right? Like myself right now, I'm talking to a laptop. I'm not talking to a human being. So we're already talking to machines. So in the future, it will become more common. Yeah. Other than that, the expansion of communication environment. Later on, I will show you that instead of just two-dimensional, where we're talking about two-dimensional, when you're talking about flat surface, we're talking about three-dimensional communication. The Earth, in the two-dimensional of the Earth, and the sky. So you got three-dimensional there. So it's a 3D communication rather than a 2D communication. Then you also go into the cyber physical fusion, where you have you go into a new dimension. If you have watched the Doctor Strange and Multiverse of Madness, then you know about the multi-dimensional or multiverse that we're talking about. Even like, for example, in Facebook, they're already talking about a metaverse, the second Earth, where this second Earth is actually a meta universe. You can create your own universe there, right? So this is an example of a cyber physical fusion, right? So going back to the timeline, right? So I've mentioned about the 10 years gap, yeah? So standardization is not an easy process. It takes a long process. You know, similar like coming up with a rule. For example, in Malaysia, let's say we want to create a new law. Let's say a law to for the under 18 to actually vote. How long does it take? It takes like months or even years to actually come up with the law. Similarly here, we want to come up with a standard. It takes a very long time. You can see there is a time where it takes to study the basic concept. It takes time to study the technical specifications. It takes time for the R&D to actually go on and do the experimental. Then only you come up with the standardization process and the implementation process. So there is a timeline set, that is 2030. They already said it. It's another 8 years from today, but there is already research going on. So in continuation with 5G, where it's release 15, release 16, and release 17, is already looking at release 18 in the year 2023, release 19 in 2025, release 20 in the year 2027, and release 21 in the year 2028. So the process is already there, the planning is already there. And they have what is called the World Radio Communication Conference, or WRC, about a few years. So during that time, this is where they debate, they discuss, and come up with the standard. So the process is long. It's not going to take one day. So Rome is not built in a day, right? So similarly, a 5G standard or a mobile standard is not coming out in one day. So it takes a few years to actually come up with it. So some of the elemental technologies towards beyond 5G include an ultra-fast and large capacity. So it's an expansion of the enhanced mobile broadband that we're talking earlier. Ultra low latency, we're talking about zero latency, 0 milliseconds latency. Numerous connectivity, instead of just simultaneous one connection, you have multiple simultaneous connection. Low power consumption, we're talking about energy saving, right? Ultra security and resiliency, right? So perhaps some of you are not in telecommunication sector. I'm sure those in the audience and those listening on Webex, I'm sure not all of you are actually from a telecommunication background. So 5G or 6G is not necessarily talking about telecommunication alone. So if you are in electrical engineering, for example, you can still be part of this Gen 6G because there are some research that are looking at how to conserve the energy, for example, saving the battery lifetime, how to actually make sure the power is as low as possible. So there are a lot of research related to electrical. If you're from a computer background, for example, if you look earlier, 6G will have a lot of incorporation of AI and also software based. So you can get involved even if you are taking computer engineering or even IT, for example, you can be part of the 6th generation because there are some IT components, there are computer components. For example, here we're talking about photonics. There are, if you're taking photonics engineering, there are security. If you are looking at encryption, for example, you're looking at network security, you can also be involved. So it is actually all sorts of engineering background that can be part of this 6G or beyond 5G. It's not necessarily telecommunications alone. So there are some assumptions made on 6G. Looking at the assumptions, first of all, they are talking about AI. AI is a hot topic now. So everything will be the domination or the main dominant in 6G will be on AI. So especially in the delivery area, in the core and edges network, devices like smartphones, IoT, etc. Right? And then on the applications itself, as I mentioned earlier, now people are talking about virtual reality, people are talking about augmented reality. But in the future, there is also what is called a mixed reality, where perhaps we use sensors other than your touch or other than your eyes and your ears. You probably use your touching sensors, smell, etc. Right? So, and then combination of all this is what is called the extended reality or XR. So these technologies will become something that is going to be common with holographic projectors. Remember that holographic was introduced back in Star Wars in 1970s when Princess Leia came out from R2D2, right? So that is about 50 years ago, right? And up till today, we still have not actually implemented. So it may come in the future, right? And actually, some of these things that appear in sci-fi movies, if you're really a big fan of sci-fi and whether it's the 1960s, 70s, 80s, 90s, or even the latest sci-fi movies, actually you can get some ideas of what kind of technologies will be there. Because once people think about it to appear in a movie, actually people already thought it outside of the movie and people can adapt it, become a research and become reality, right? So it will be cheaper in the future to maybe communicate or augment especially in terms instead of just displaying or instead of just a 2D layer of representation. Okay, so the 6G requirement include an infinite capacity, that means a high data rate. Of course, all are looking at higher capacity. Coverage, 3D coverage. Remember, the 5G is still looking at 2-dimensional. Now 3D is looking at 3-dimensional, where it's also looking at the sky, right? And also location. It's a zero latency network. There is a very, very small latency, extreme low power and energy free connectivity, right? So the comparison, as you can see, the speed right now, we are talking about 10 to 20 gigabits per second, but they are talking about going up to 1 terabits per second. And the experience is latency is even lower, right? So it's going even lower than 0.1 milliseconds. And instead of 2D, now they are talking about 3-dimensional. So how can we achieve all this? It's quite difficult or a high target, like when you set a KPI, it's just like a university KPI, or when you work later on, you have your KPI, or even for your subjects, definitely you have a certain KPI. There's a very high KPI target. In wireless, it's not that easy to achieve 10 gigabits per second, and to achieve 1 terabits per second. Wow, that's a huge target to achieve, right? That's a very high target. But there are a few trends in 6G. This is called a mega trends. I'm only taking some of them. Actually, there are more than 5. There are about 8 or 10 trends, mega trends that are currently going on. Looking at trend number 1, which is looking at the bits and the spectrum. Trend number 2 is spatial bandwidth, 3D coverage. Trend number 3 is new technologies. Trend number 4 will be looking on convergence of communication, caching, and control. And finally, trend number 5 will be on the AI, right? So when you talk about wireless, one of the important things is spectrum, the frequency spectrum that is being used. Yeah. So up to 5G, 5G is using these 3 frequency bands. There is a low band, mid band, and also high band, which is about 28 gigahertz high band, right? So there's a lot of frequency bands being used. Why do we need to go for a higher bandwidth? Because what we want is more data. More data means you need bigger spectrum, right? So is at bigger spectrum will need bigger spectrum can carry higher data. But in order to get bigger spectrum, you need to go to the higher frequency band. So that's why you can see at the higher you go, the bigger the frequency, the bigger the spectrum, or the bigger the bandwidth that you have, right? But the problem with this, right? This is what the spectrum looks like. It's crowded. There's so many things going on, right? This is what it looks like in Malaysia. You just imagine in any countries. There are so many wireless applications there. Each wireless application or technology is using a specific spectrum. So spectrum planning for the spectrum is not easy. So that's why for 6G, they are looking for an even higher spectrum. So if 5G is going up to about 28 gigahertz, so 6G is looking for a much higher frequency than the 28 gigahertz. So right now, a lot of research are moving towards what is called the sub-terahertz spectrum, right? And these are some of the frequency of interest, right? You can see here about up to about 200 gigahertz, yeah? And these are some of the scenarios for the spectrum use, right? So more spectrum above 90 gigahertz means you get more data. So there is bigger bandwidth. That means more data can be transmitted. That means a higher data rate. Then you can achieve a much bigger data rate. But of course, nothing comes easily, right? There are also some challenges. So this is where research comes in, right? Actually, for researchers, we do like problems. So when there is a problem, there is a solution, or there is a way to solve, right? So there are some challenges in sub-terahertz, right, where we are talking about the propagation issues, right, and the attenuation, the effect from the space, etc., right? Okay. So there are some solutions. I'm sorry that I have to go a little bit faster. It's already 6:45 and we have a few questions. If you do have questions, you can type it in the chat box. These are some of the solutions that is currently being researched on. Beam forming, beam steering. It's nothing new. Even in the third generation, fourth generation, they already come up with this. But in the fifth generation, sixth generation is even bigger, right? So they're talking about antenna, they're talking about smart antennas, etc. Right? And then visible light communication. This is another way to exploit the spectrum. So if you go back to the spectrum earlier, you can see that currently all the radio signals are below the visible light. Right? So the reason why visible light is the light that we see in our room, the bulb, the LED lights and so on, the visible light, well, it's called visible light. So the light that we see, right? So anything below the visible light is something safe because this frequency band are non-ionized bands. So anything that is below the visible light is safe. Or else the visible light is, if below visible light is not safe, then visible light is definitely not safe, right? But we have visible light every day in our life. We need the light to actually lit up our house and so on. So we have visible light. So visible light, that means if you go up to visible light, you have a much bigger spectrum to use. So this is one of the research that is also being carried out, right? So I'm also doing something in visible light communication. Right? The second trend that they're looking at into the 3D spatial bandwidth and 3D coverage. So when we talk about 3D, you're not just talking about the surface on the earth where that is a two-dimensional. We are also talking about sky. So sky, in this case, there are a few types of technologies that is also being discussed for sky or for surfaces. I will talk about that later on, right? But there are, like, for example, UAV, the HAPS, satellites, etc. can be part of the sky network services. Yeah. So this is also another area if you are interested to do your research on. It can be something that is interesting to look at. For example, we have what is called the flying FlyNet, yeah, flying ad hoc network, flying ad hoc network using drones, for example, right? Where you use drones as an ad hoc base station. Yeah, so that is also another research area. Then there is a trend number 3, new technologies, metamaterial in memory computing and quantum computing. This is also another research. I think Min actually asked me to stress on this. Is a reflective intelligent surface, or sometimes called the intelligent reflective surface. This is also another research that I'm currently carried on. Is about the material that is used as an extra reflective surface for places that are not achievable by the signals. That means it is the signals were not able to reach the receiver. Then we have a reflective surface that can be smart enough to remove some of the interference coming in. Like, for example, here it can use at the cell edge that it can cancel out the other ones for security purposes and so on. So it's using what is called meta materials, materials that is a special materials that is used as a reflection surfaces. The third trend is a C to the power of 4, or C4. It's a continuation of C cube. This was supposed to be C cube, right? It's a convergence. In MMU we have I cube. Yeah. So in here we have C to the power of 4. It's communication, computation, caching, and control, right? So this is involving the integration between the 6G network and also the other connectivity. Like, for example, here it will be indoor using millimeter wave, terahertz, visible light, and then a cellular mobile communication system, and then a satellite communication. So you merge all of this together, right? So the 3D coverage that I was talking earlier, the 3-dimensional, we're talking about the what do you call that? The 3D coverage. perhaps this one is looking at the integration with, there are a few technologies that is already there. Flying base stations, this is the FARNet that I mentioned, is a flying ad hoc network. You can search on this word. Then we have the HAP, which is high altitude platforms. It's like the air balloon, but is in the sky, but it becomes like a base station. Very low Earth orbit satellites and geo satellites, which can also be used as base stations. And I think, like for example, Elon Musk is also launching their Starlink satellite links, which will become some sort of the integration between satellite internet and also the landline internet, right? And that is actually for 5G enhancement, right? And then the last trend that I'm going to talk about, or I include here, is on ubiquitous support of AI and the path for fully distributed intelligence. So the quest for more distributed intelligence in memory computing, less data traveling time, in memory database, in memory applications, new programming model, and also in terms of computational caching. All right, I actually have another video to share, but I'm not sure if we do have the time. This is called 6G Vision for 2030. I think you can search for it on the internet, YouTube, because we only have about 9 minutes left. I prefer to reserve it for the Q&A if there is any. Right? Actually, I want to conclude this. We are actually still in the early stages of rollout of 5G and still have a long way to go with the evolution of this technology. So technology always change. So that means we are not fixed to one. Yeah, just look at, for example, last time we used to use dial-up. Yeah, 20 years ago we used dial-up. We moved towards ADSL, which is still using copper. Then now we move towards fiber optics, and later on we're probably going to use a wireless broadband rather than fiber optics, because fibers will be more expensive. Although there is what do you call that, difference between wired and wireless. I don't have time to cover the difference between wired and wireless now, but there is a much difference, because there's always an advantages and disadvantage for each one. So the right time to be asking what is next and the right path ahead of us appears to be reached. So beyond 5G is there, 6G is there. There are a lot of research ongoing into 5G and beyond 5G and 6G. There are many in telecommunications, and not just communication, as I stressed earlier. If you are in electrical, if you are in photonics, if you're in microwave, if you're in computer, even if you're in nanotechnology, if you're in electronics, there will be an area that you will have that can link to this 5G and 6G, right? But of course, in order to achieve a very high goal, a very high KPI, there will always be challenges. Nothing comes easy, right? Just like your studies, if you're studying now for your degree, I'm sure it's not an easy path. But once you're over it, you will see like, wow, how did I make it? How did I ever reach at the end? So this is similar to technology. At the beginning, it's very rough, but when you reach at the end, you will be satisfied with what you have achieved. Yeah. So I think that will be all that I'm going to touch on. I will these references. I took most of the parts from Dr. Emilio's presentation on 6G, the next frontier, vision, roadmaps, and technologies in 2019. And also the latest one, if you want to get the latest news on this, will be from NTT Docomo. NTT Docomo has a white paper called White Paper 5G Evolution and 6G. It was published in January this year. It's version 4.0. So I think that will be a good read because they are very, not too technical. It's quite, not to say relaxing also. It's a bedtime story. Yes, definitely. Okay. So that's all. If you need anything, you can email to me. Someone was asking, I go to the questions. I can see that in the chat box. Yeah, there's a few questions there. Of course, most of the questions were asking whether I can share the copy or not. I will discuss with the organizers, yeah, whether we can share the slides or not. And then probably if not the slides, maybe we can share the video. They have done the recording. We can also share it on our YouTube. Yeah, don't IEEE ComSoc actually have our own YouTube channel. You can search on YouTube, and also on Facebook. We have a lot of materials, a lot of lecture sessions, and so on. In fact, we will be having our summer school series that is open to undergraduate, postgraduate, diploma students, any students that will be interested into AI applications in communications. It will be, we'll be having it in June, from June 20th to June 23rd. It will be online, so you can, even if you cannot travel from Curtin or from anywhere else, you can actually register online. It will be totally online. Originally, we want to have hybrid, but because of some problems, we'll be converting that to 100% online. So you can be wherever you are, and you can join that summer school series. It's free for ComSoc student members. So join ComSoc. It's only $1 to join ComSoc. So I promote a little bit about ComSoc. Okay, there's one question that I think was asking about the 5G, about affordability. Someone was asking about how about the affordability of 5G? Is it affordable or is it not affordable? Right? Basically, if you look at how technology adoptions is, yeah, normally the price will be expensive at the beginning, but as time goes by, that's why you have competitions. When there are more and more competitions, the price will drop. That means users will benefit from it. Yeah, user will benefit from the competition among the service providers. So hopefully in Malaysia later on, at the moment it's only one provider, DNB, Digital National Berhad, that is providing the services to the telcos. So telcos have to purchase from them, and then they provide the services. So I won't be able to comment much on the prices and so on because I'm not in economics. So I won't touch that much on that.
All right. Thanks, Prof. Yusoff.
Okay, back to you, Garen.
Thanks, Prof. Yusoff. I'm Garen from this hybrid class. So I think we have the audience have a questions, because most of our audience here, they are 3G babies, right? So they never experience 1G and 2G. So thanks for your interesting sharing. I think you have shared 100 years history for them. So what is your question?
Not 100 years lah. I think it's always about 50 years.
Just ask him. Yeah, there's a question here.
So
Okay,
ask
sure.
the material part of the slides that you show, was it just for reflecting the radio waves within like an indoor environment?
Yeah,
Okay.
Prof. Yusoff, let me recap. He said what kind of
I can hear that question.
Yeah.
Thank you. The question is about metamaterials, whether
Yes.
it's only for indoor. Actually, if you search the intelligent reflective surface, IRS, or RIS, you can see that the applications is not necessarily for indoor only. It can be implemented both outdoor and indoor. So there are some RIS using metamaterial surfaces that is being used for mobile communication, for satellite services, and it can also be used for indoor, for example, for Wi-Fi services. So it can be used for both outdoor and indoor. Hopefully that answers your question.
Prof. Yusoff just wondered the RS, what is it a short form RS?
Yeah, RIS is reflective intelligent surface. I'll type in the chat.
Okay. Is another question?
Yeah. Aside from reflection, are there also metamaterials that allow like certain spectrum of lights through to like in a wall, like a material that instead of blocking the signal allows certain spectrums to pass?
Okay, thank you. Yes, correct. basically radio signals, when it hit a material, there is a specific type of materials. It depends on the, what do you call it, electrical properties of that particular material. So the electrical properties of the material will actually determine whether the signal will be 100% reflected, whether some of the signals will be absorbed and only certain portion or certain percentage being reflected, or it will be absorbed 100%. For example, ground is a good example of a lossless medium. That means a ground is actually 100% reflection. So there is no absorption, there is no signals that are being absorbed into the ground. So all radio signals will be reflected by the ground. So different materials will have different electrical properties. The electrical properties of the material will actually determine how much of the radio signals or which frequency of the radio signals will be absorbed or which frequency will be reflected. One good example is the absorbent, the soundproof room. If you look at a soundproof room, right? So soundproof room, they have a material that they put on the wall so that it can absorb the sound wave, right? So that the wave doesn't get reflected. So similarly, a radio signals is a radio wave. So there are certain materials that will not be able to allow radio to go through. There are materials that allow radio to go through. So the metamaterials, in the case of RIS and IRS, of course, it's thank you, Lau. There are a lot of short forms here. So if you look at the definition, there are many RIS and IRS. Maybe there's a island intelligence service or something that would be, or Russia intelligence service can be RIS also. So the material that we use for RIS and IRS, what happened in communication, what we do is that we control, there is a controller that will change the weight vector, that we can adjust what kind of signals can be absorbed, what kind of signals can go through. So that is sort of like an intelligent reflective, that's why it's called intelligent reflective surface. So it's not only a reflective surface, but as is an intelligent one.
All right. Thanks, Prof. Yusoff.
Okay, all right.
Any more questions?
Any questions? Any other questions?
There are some questions on the chat. But before we answer the question, can I have everyone to turn on your camera? Okay, those who are in the hybrid, can you just close to this camera? Come over. This will be shy. Those who are on the Webex, can you turn on your camera just to have a good photo with our speaker? Just sit over there. Just sit near to this camera. Guys, just come over, come over. I can see you. Okay, turn on the light. All right, any more? Anyone will turn on your camera? Okay. Okay, I think just 1, 2, 3. If you are not wearing mask, you smile. If you are wearing mask, I can see your smile. So, okay. 1, 2, how to print screen? Okay, 1. Okay, 1, 2, 3. Okay. Right, done. Thanks everyone. For those who are still having questions, you can stay and ask Professor Yusoff. Okay, those who are in hybrid, yeah, I think you are rushing.
Thank you, Prof. Thank you, Prof. Yusoff.
Okay, thank you for coming. Thank you for
Very
joining.
good discussion, Prof. Thank you.
Thank you. Thank you to all those that joined me today. I hope it's not too long. I know it's normal for a lecturer, once you get the chance to speak, it's difficult to stop. So there are a lot of things to actually talk about. Thank you everyone for joining. I think there are a few questions here. I also can stay only for another few more minutes. I can only stay about another 6 minutes.
It's a question from Arbola. What is the side effect of 5G and 6G to the human? Prof. Yusoff?
Very good question, that one. Okay, there is another question before that. How about the unlicensed radio technology like LoRa? Will it disappear after 5G implementation? Okay, for the question by Abdullah, what are the side effects, if any, of 5G and 6G? Actually, as I mentioned, there is no problems in terms of health hazard because the radio frequency band that we use is actually below the visible light. So when you are below visible light, I actually have it here. So as long as it's below visible light, then you will be able to actually all the signals below the visible light. So you can see here, this is a visible light. This is visible light. I use red color. So anything that is below visible light, this is the radio that we are using for our daily life. So all these radio are called the non-ionized radio, non-ionized. So if there is no side effect to our health for these non-ionized signals. We have been living with all these radio signals all our life. We have been living with the visible light all our life. So all the signals are non-ionized. But there is a restriction in terms of the amount of power that can be transmitted, usually by the regulatory body, because there is also heat that is coming out. So not necessarily the wave, but the heat that is introduced. You know, like energy convert from one form to another form. So energy cannot be destroyed. Energy just convert from one form to another form. From electrical energy to a radio wave, and then which is a kinetic energy, then it moves towards the heat, which is another form of energy. If it is above this is the dangerous one, which is the one above the visible light. This is the dangerous frequency band. So this is called ionized band, for example, X-ray. So you cannot go to X-ray more than once or more than twice, right? Or if you go to gamma ray, you become Incredible Hulk, right? So Hulk, Bruce Banner actually become Hulk because he was exposed to gamma ray. So if you want to become Incredible Hulk, then you can go to for gamma ray. Yeah, but on jokes on the side, basically anything that is above visible light, even UV, ultraviolet, can actually affect our skin. That's why we have a skin protector and so on. So anything above visible light is dangerous because it's ionized. Anything below visible light is okay. Yeah, so it's none. I hope that answers your question, Abdullah. As long as 5G, 6G, 7G that is below the visible light, it should be okay. Another question, I think this is the last question from Rabia, about the unlicensed radio technology like LoRa. Will it disappear after 5G implementation? Actually, I didn't cover on that. In IoT. IoT is nothing new. So there have been a few technologies using for Internet of Things, and one of it is LoRa. It's a low radio, wide area network, LoRa 1. So LoRa is a low radio. So low radio is using a lower frequency band. For example, the unlicensed radio frequency band is even lower than 1 gigahertz. So that this frequency band can be used for LoRa. But LoRa is a proprietary. That means it's not a standard. So it's only belong to that one particular company. So that's why you don't get that many devices using LoRa. So there's only one company that produce LoRa, LoRa 1, and so on. Similarly, they have, like, for example, NB-IoT or narrowband IoT. There are a few different types of other IoTs as well. So there are different IoT types, but most of them are proprietary. So that means they belong to only one company. Will it disappear after 5G implementation? We yet to see that. But one of the reason why 5G is there is for IoT implementation. So IoT is easier to be implemented with 5G because it can be linked to any network. Unlike LoRa, where you have to connect to LoRa 1 and LoRa 1 connect to the server. So in 5G, that means you can just connect to the 5G network. As long as your server is also connected to the internet, then you can connect the whole system. that. Hopefully that answer your question, Rabia. So it may be a competition to LoRa. We have not seen yet whether it's going to make LoRa disappear or any other IoT systems disappear or not. Okay, so I hope that answers your question. I think that's all the question I can take for now, because I also have to go.
Yeah, thanks. I think Prof. Yusoff, thanks everyone for joining.
Okay.
I think thanks for the sharing. Is inspiring and also quite informative. You cover 1G to 6G. So thanks everyone. For those who are from Curtin, you need to stay back for a while. You need to fill in a feedback form. For those who from not from Curtin, yeah, I think you can go. I mean, good night and see you everyone.
Right. Thank you.
Thank you, Prof. Thank you.
Bye.
Assalamualaikum. Thank you.
Salam.
Okay, thanks, Prof.
Bye. Thank